Good morning, stats. We are on to 3.6, the last section we're going to do this week. We're going to have a review day and then a quiz on Friday. So we are looking at observational studies and experiments. We talked a little bit about this in 3.1. It was mostly the observational studies. We're going to get into the experiments a little bit more. So moving along here to objective one, we're going to explain the concept of confounding and how it limits the ability to make cause and effect conclusions. Okay, so unfortunately, when you have an observational study, it makes it very difficult to identify cause and effect relationships. If all you're doing is observing, there is no cause and effect. Okay, so confounding occurs when two variables are associated in such a way that their effects on a response cannot be distinguished from each other. So we find something happens, but we're not sure if the reason that it happens is because of a certain other variable. There's no way for us to distinguish and tell that. So observational studies cannot definitively show a cause and effect relationship. Sometimes it seems like it's common sense, but we can't prove it. So between an explanatory and response variable because of confounding. To identify confounding, think about other variables associated with the explanatory variable. So when we go through this first example, this is going to be key. You're going to think about other variables that could be associated with the explanatory variable that might cause a change in the response. And as I do this first example, I'm going to kind of explain that confounding and what else could be an issue with that. So here's a first example. Can ADHD be linked to mothers who smoke? So, in a study of more than 4,700 children, researchers from Cincinnati Children's Hospital Medical Center found that those children whose mothers smoked during pregnancy were more than twice as likely to develop ADHD as children whose mothers had not smoked. Based on this study, is it reasonable to conclude that a mother smoking during pregnancy causes an increase in risk of ADHD in her children? Explain. So, the fact that we had a study of 4,700 researchers found that those children who smoked. So this right here isn't just an observation, okay? And this word right here, causes, does it cause, we have an issue with, okay? So for this problem, okay, it says to explain. We would say no, okay? And although smoking during pregnancy, may increase the risk of ADHD, it is possible, in children, it is possible that the mothers who smoke during pregnancy were also, and here's where you make something up, more likely to have a poor diet. Okay. So what else could a mother, who, since we're just observing it, what else could that mother have done? We could have mothers who smoked during pregnancy possibly could have had it hereditary in their family. Mothers who smoked during pregnancy could have also been drinkers, and maybe drinking or drugs also influenced ADHD as they were pregnant. So it's not just because of the smoking, and we can't prove that it's just because of the smoking. Okay. So we could say perhaps, and I just used an unhealthy diet. Okay. You're just going to choose one. Perhaps it was the unhealthy diet that caused the increase in ADHD risk. Not smoking. Now, we don't know whether a poor diet Okay, again, because it's just observational, we don't have anything to compare it to, so we can't definitively say. And again, where did I come up with a poor diet? I just made it up, an unhealthy diet. You make up something else that could possibly change the data. Okay, so even though it shows that smoking was, happened twice as much, there was no cause and effect to prove that that's the reason there was the increase. Could have been something else. Okay. Um, all sorts of different things could play into this ethnicity. Like I said, unhealthy diet, is there drinking, other drugs involved, hereditary issues, all sorts of different things can be linked to that. So you need to show one other method that could have caused the increase in whatever we're discussing. In this case, it's ADHD. Okay, on to objective 2, explain the person of comparison in an experiment. So we're going to have a treatment. Treatment is a specific condition applied to the individuals in an experiment. Okay, then the experimental units, smallest collection of individuals to which treatments are randomly assigned. We call humans subjects. Happens a lot of time when it comes to vaccine experiments. Then we have a control group, a group in an experiment used to provide a baseline for comparing the effects of other treatments. The control group are the people that did not get the actual, whatever we're looking to prove or show the side effects of. Okay, so note, conducting a well-designed experiment is one of the best ways to prevent confounding. Okay. So the example here says, what devices get customers to conserve electricity? Many utility companies have introduced programs to encourage energy conservation among their customers. An electric company considers placing small digital displays in households to show current electricity use along with the projected monthly cost. Will the displays reduce electricity use? One cheaper approach is to give customers a chart and information about monitoring their electricity use from their outside meter. Would this method work almost as well? The company decides to conduct an experiment to compare these two approaches, the display, the digital display, and the chart, with a control group of customers who receive information about energy consumption, but no help in monitoring the electricity. So the control group gets nothing. They're just given, hey, this is what happens when you use your energy. Explain why it is necessary to include the control group. They need something to compare it to, right? Okay. So the purpose of the control, and again, this is kind of a memorized answer here. Okay. The purpose of the control group is to provide a baseline for comparing the effects of the other treatments. Right? What are the two treatments that we're comparing to? The one is you're just given information and nothing else. And then the two that we're looking at is the display, the digital display, where you don't have to do anything and it kind of shows you, hey, I got all these lights on, I better turn them off. Or a chart where we would actually have to go and do that ourselves. Okay. Otherwise, we wouldn't be able to tell if the displays or charts caused a reduction in electricity use. Okay, so again, you got to have some sort of control group. Okay, so why is it necessary to have a control? The purpose of the control group, this is a memorized answer. The purpose of the control group is to provide a baseline for comparing the effects. Okay, in this case, what are we comparing? The chart versus the digital display. Okay. Objective 3, describe the placebo effect and purpose of blinding in an experiment. So the placebo effect here is the fact that some subjects in an experiment will respond favorably to any treatment, even an inactive treatment. The placebo is a treatment that has no active ingredient, but is otherwise like other treatments. So a lot of times you'll be given like, if we're doing a vaccination or, to see how a pill works, there'll be a pill. They look exactly the same, but one pill has the active ingredients and one pill does not. And they don't know which one has the active ingredient and which does. Okay, of course, a placebo isn't that useful if a subject knows he or she is getting a placebo. So again, if they tell you this pill is going to make you feel better, um, and then they say, but you don't have the active ingredient that is going to make you feel better, well, then they're going to, of course, not think they feel better, knowing that they don't have the active ingredient. Okay, and then the other thing for this is um, the blind experiment. A double blind experiment is when neither the subject nor those who interact with them and measure their response variables know which treatment a subject receives. So it's completely blind on both ends. The people that are giving the experiment don't know whether or not you have the true active ingredient or not, and the people receiving it do not know whether or not they have the true active ingredient. And then they ask how you feel. These are usually the best type of experiments when it's double blind, because you may have a company that really wants to have a pill or a vaccine go into place so that they can sell it and make money off of it. So they could skew the data one way so that it looks good if they know it. So that's what a single blind would be. So either the subjects don't know which treatment they are receiving, or the people who interact with them and measure the response variable don't know. So think about it, if the people that are given the pill know, and the other people don't, they're going to they could ask questions to skew the way that they're feeling to make it seem like the medication that they're creating feels better. So double blind experiment usually is the best option there if we have that. Okay, so let's look at the last example here. It says, do magnets repel pain? So early research showed that magnetic fields affected living tissue in humans. Some doctors have begun to use magnets to treat patients with chronic pain. Scientists wondered if this type of therapy really worked. They designed a study to find out. 50 patients with chronic pain were recruited for the study. A doctor identified a painful site on each patient and asked him or her rate of pain on a scale of 0 to 10. Then the doctor selected a sealed envelope containing a magnet at random from a box with a mixture of active and inactive magnets. The chosen magnet was applied to the site of the pain for 45 minutes. After being treated, each patient was asked again to rate the level of pain from 0 to 10. In this experiment, the patient didn't know which type of magnet was being used. Explain why this is an important consideration. Okay, so again, if you have somebody that has chronic pain and you say, hey, I'm going to put a magnet on you that has no magnetic field at all, this won't do anything, isn't that person going to be more likely to say, yeah, that didn't work? As opposed to saying, we're going to try this magnet and not tell them exactly, what the active ingredient magnet was. They may have a different opinion after 45 minutes. Okay. So if subjects know they are receiving an active treatment, researchers wouldn't know if any improvement was due to the magnets or to the expectation of getting better. Okay. That would be the placebo effect, right? You tell somebody, hey, I'm going to put this magnet on you and it's going to make you feel better. Um, Obviously, their mind's going to tell them after 45 minutes that, yeah, this should make me feel better. So again, 3 different objectives there, some definitions. Make sure you write those down and are able to go back to those. So you got a few problems in Edulastic, and that will kind of wrap up this week's notes here. Do a review on Thursday and a quiz on Friday.